So hi everybody. Remember last class we talked about this, right? And we were training your brain to kind of think about two questions. What operation are we doing? Whenever we see a transformation, what operation are we doing? Or is it on the inside or the outside of the function? That would lead us to a horizontal shift, a horizontal uh, stretch or compress, or a reflection, or any one of these guys: vertical shift, horizontal shift, vertical stretch or compress, horizontal stretch or compress, or reflection, just by answering these two questions here. So now that we know what type of transformation it is, we're going to dive a little bit deeper and talk about what, by how much. Okay, if it's a vertical shift or a horizontal shift, by how much, and how do I recognize that? Okay, so here I took a snip or a screenshot of the first part of our handout. Okay, this is vertical shifting and horizontal shifting, right? So an example of vertical shifting would be f of x equals absolute value of x plus 4, right? Remember in this in this exercise, our parent function is the absolute value of x. Okay. So with the plus 4, okay, or the plus k, or yeah, we just treat it how it is. Since this is a vertical shift, that means that I'm getting my graph here, right? I'm gonna draw the graph out again. Okay, that's my parent function. Looks like a V. I'm getting that, and I'm shifting this up or down, right? So each and every point on this function, I'm going to either shift it up or shift it down. Okay? Literally picking it up and moving it up, or I'm moving it down. Okay? Does that make sense? So the plus 4, you can take it for what it is. We're actually moving this up 4 units. All right? So that's why a vertical shift plus k. Okay, we're shifting it up k units. All right? If you see a plus, then you're just moving it up. If you see a minus, you're just moving it down k units, whatever that number is. All right, graphically. Okay. Now, before I talk about the point, our first parent function, and the one that we're going to be transforming again, is the absolute value of x. The parent point of this, meaning if I wanted to graph absolute value of x, is what we already know how to do. -1 or -2, -1, 0, 1, 2. The absolute value of -2 is, what is the absolute value of -2? 2. What's the absolute value of -1? 1. What's the absolute value of 0? 0. What's the absolute value of 1? 1 and then 2, right? Yeah. So if I graph this here, on my x and my y. -1, -2, 1, 2, 1, 2. Okay. 0, 0, -1, 1, -2, 2, 1, 1, 2, 2. It's going to look something like this. And it's a little bit off because I did it without a graph paper, right? My spacing is kind of off. But you guys see how it's a V? And this point here, that's my vertex. Okay? That's the vertex. And if I'm and if I am shifting this by 4 units, f of x equals a vertical shift, 4 units. What does that do to this graph? What am I going to do from 0, 0? The 0, 0 point becomes 0, comma 3, 4. 4, right? Right there. -1, 1 becomes -1, 5 right here. Yeah, and so on and so forth. I'm just going to move these up 4 units. So now it looks like this. Does that make sense? Yeah. So my parent function, I'm just going to take one example, 0, 0, turned into 0, comma 4, right? What's the change from 0, 0 to 0, 4? Well, my y value added by 4, right? I added 4 to my y value, correct? And that's what this does. Okay? That's what that does. So if it's a vertical shift up plus 4, that means I'm going to add 4 to my y value. All right? If it's minus 4, I'm going to subtract 4 from my y value. Okay? Anything vertical, remember, is your y value that's changing. Anything horizontal, that means that your x value is changing. Okay? And it all stems from those two questions, right? We all know that it's a horizontal something or vertical something based on if it's on the inside or the outside of the function. Okay? All right? So vertical shift is actually the easiest one to kind of recognize. Okay? Because you just take it for what it is. Okay? Now let's look at horizontal shift. Horizontal shifting, like f of x equals absolute value of x minus 4. Okay? I'm going to put my parent points back up here. -2, 2, 1, -1, 1, 0, 0, 1, 1, 2, 2. Okay? X, y, and then f of x equals absolute value of x. Okay. Now, if this was my transformed graph, right? I know it's a horizontal something, right? It's a horizontal shift. And we just understood that horizontally, we just said horizontally means x values are changing, correct? So if my x values are changing from my parent point, let's take 2, comma 2 or -2, comma 2, right? I know my x values are changing, so it's going to be blank, comma 2. Does that make sense? Yeah. It's a horizontal something, so my x values are changing, right? So here, if we look at it, x minus 4 absolute value of x minus 4, this function here. If absolute value of x minus 4 equals 2, what does x equal? Just think about it. Don't do anything algebraic. X can equal what? 6 or huh? So it could be, so x minus 4 can either be 2 or negative 2, correct? Yeah. So 6 minus 4 is positive 2. What minus 4 equals negative 2? Negative 6 minus 4, that's negative 10. What number minus 4 equals negative 2? 2. 2, right? Yeah? So 2. So it can, x here can equal 2 or 6. Notice we have two values of x, right, when it equals 2. And we have two values of x when it equals 2 because y equals 2 here and here. Does that make sense? We have two y coordinates valued 2. So that's why we have two x coordinates, 2 and 6. Right? Okay. I'm going to just tell you this one, the negative 2, led me to 2. Okay, so this point is 2 comma 2. What changed? Well, I added, what changed from negative 2 to 2? What is the change in that? It's a plus 4, right? Yeah. From negative 2 to 2, we're adding 4. Correct? From from this number here to this number here, we're adding 4. But look at the function itself. It's a minus 4. Well, if it's a minus 4, we think, right, it's going to be moving to the left because that's what minus is, right? But in actuality, we're going to be moving to the right because we're adding by 4. Because we are adding 4, right? We're actually moving the whole thing. We're shifting this thing to the right h units. Okay? So minus, horizontally minus means right. Plus means left. Okay? So you have to kind of think opposite. Here. Okay? Let's try the same thing with 0, 0. I'm going to erase all of this because I only have 1, 0. 0, comma 0 led me to blank, comma 0, right? So if I have x, absolute value of x minus 4, right? If the absolute value of x minus 4 needs to equal 0, What does x equal? It's not a trick question. Yeah. 4 or 0. Sorry. 0, right? Oh no. My first number was correct. 4. Correct? Yeah. Because 4 minus 4 equals 0. And the absolute value of 0 is 0. Right? So you guys see how we went from 0, 0 to 4, 0? So that means my x value grew by 4 units. Right? We added 4 to the function or the x value. Right? But this guy here is negative, or is a minus 4. So whenever we're subtracting 4, whenever we're doing anything horizontal, you have to think opposite. Okay? So the train of thought is, oh, I see a minus 4. I know it's a horizontal shift. So minus on a number line means to the left or to the right. On a number line. If I have an old number line here, 0, -1, and +1, minus means to the left, correct? Normally, right? But when we're graphing, we have to think opposite. So since it moves to the left, we're actually adding by that number. We're actually moving to the right. Okay? Questions on that? So we just talked about horizontal and vertical shifting, right? And what makes it, or by how much, depending on, just to sum up this and then moving on. If we're adding k on the outside, that means it's a vertical shift up k units, okay? And then how that affects it is you're gonna add k to my y value. If it's a minus k, like a -3, we're shifting the graph down 3 or k units. And that means that means we are subtracting k to my y value. All right, because it's a vertical. Horizontal shift, if we're adding h to the inside of my function, like a x plus 2, right? We're actually, you see a plus 2, so you think it's going to be to the right because it's a horizontal, right? But it's actually to the left, h units. So then if it's to the left, we're subtracting h, or x minus h. That's what we're going to be doing with the points. And if it's x minus 2, right, just like this, you think it's going to be to the left because you see a minus, but you got to think opposite, so it's to the right, h units. That means we're adding h to our x value. Okay? That's shifting. All right? Our next transformation is vertical stretch or compress, or horizontal stretch or compress. Okay? My first example, and again, oops, not 3. I was thinking 3. X. All right. So my parent function is f of x equals absolute value of x, right? And let's say there's going to be a 3 times the absolute value of x. That 3 represents a vertical shift or a vertical stretch or compress, correct? If it's a whole number that we're multiplying by, it's going to be a stretch, okay? So if it's a whole number like a times f of x, a in this case, in my example here is 3, it's going to be a vertical stretch by a factor of 3. This is how we write it, by a factor of 3. All right? And what we're going to do with the x and the y's, the coordinates, is we're going to be multiplying 3 to the y value. All right? Let me show it to you guys graphically. Okay, so this is graphically. All right, oops. And then you guys can see the red is absolute value of x, our parent function. And the blue is actually 3 absolute value of x, the transform one. Okay? And you guys see how it's skinnier? Right? Because if you stretch a rubber band, right? Stretch it out, it's going to get skinnier like this. So that's why it's a vertical stretch. Okay? Some things here, 0, 0. 1, negative 1, 1. Okay, I'm pretty close to it. Turned into negative 1, 3. I'm pretty close to it too right now. You guys see that? Me. Okay. Again, negative 1, 1 right here, this point. This point here, negative 1, 1, turned into negative 1, 3. Okay? So that's how we're going to be stretching it. 0, 0 still stays at 0, 0. Okay? So that's what vertical stretch means. Okay? So going on to my parent points, honestly, class, x, y, negative 2, 2, negative 1, 0, 1, 2, 1, 0, 1, 2. From here, from my parent function, f of x equals absolute value of x. And then f of x equals 3 absolute value of x. My new points will be what? Negative 2, negative 1, 0, 1, 2. I know my x values don't change, right? Because it's a vertical something. So my y values do. I'm going to be multiplying 3 to my y value. 2 times 3 is 6. 1 times 3 is 3. 0 times 3 is 0. 1 times 3 is 2 times 3 is. So those are my points. Okay. So honestly, with this transformations, if you know how to do this row here, right, or this column here, you guys will be good with graphing. Okay. You guys don't have to do the shifting of the graph itself, if you guys know that. Okay. So that's what it means by having a whole number being multiplied to the function. Okay. If it's a fraction that we're multiplying on the outside, it's going to be a vertical compressed by a factor of a. So if it's 1/3 absolute value of x, it's going to be a vertical compressed by a factor of BAFO of 3. All right. And again, on the inside, horizontal stretch or compress, you have to think opposite. What I mean by that is a vertical stretch was a whole number multiplied on the outside, right? And we take it for what it is. We're multiplying 3 to the function itself, to the parent function. Horizontal stretch or compress, we need to think opposite. So when we see a whole number here, f of x equals absolute value of 3x, just like that. This is a horizontal because it's on the inside. Compress, this is the opposite part. Okay. Whole number, you think it's going to be a stretch, but it's on the inside, so you think opposite. So it's a compress by a factor of 3. Okay. So what we do with a compression is we're going to divide x by a. Okay, and vice versa. If it's absolute value of 1/3 x, that's a horizontal stretch by a factor of 3. Okay. Cool. Questions? And then our last, yes. Graphing wise, we'll talk about later. Okay. So just recognizing what transformation it is and how that affects the graph and how that affects the point, right? The coordinates. That's what we're doing right now. And then plotting it on a graph is simple, if you guys understand this. So I'm laying out the groundwork. So when we're into graphing, it'll be simple. Okay, and again, if you guys know that part really well, then you guys should be good. All right. Okay, our last little bit is the quickest. You still need it up. The last little part is the last little transformation that we have is reflection. And it's pretty quick. Okay, and we already kind of talked about it, right? So let's go and do our last transformation, which is reflection. Okay, so if the reflection, if we're multiplying by a negative on the outside, right, that negative right there, like absolute value, negative absolute value of x, f of x equals negative absolute value of x, like that. That's going to be a vertical reflection, right? We labeled it like a vertical reflection. But again, if it's a vertical reflection, that means we're changing our y values, right? That means that it's going to go, it's going to be a reflection over my x-axis. Okay? across my x-axis or over my x-axis. And if it's a reflection over our x-axis, all we're doing is we're just multiplying by a negative to my y value. Okay? Because if it's a vertical, it affects my y value. And vice versa with the reflection of across the x, across the y axis, like that. Since it's on the inside, it's a horizontal reflection, right? But we don't say horizontal reflection. We say reflects the graph across the y-axis, okay? Because it's horizontal. And what we do with that is we put a negative on the x, okay? Questions on that? So I have 3 examples to kind of, or 4 examples to round out this lesson. Okay, so the first one, or what we're gonna be answering is what transformations are going on and how do we describe it? Okay, so I know anything that's not a part of our f of x is going to be a transformation. So that plus 2 is the transformation, right? Right here. Yeah. What does that represent? Well, it's on the inside, so it's a horizontal. I'm just gonna put an H. We're adding, so we are shifting. Okay. If it's a horizontal shift, by how much? By 2 units. Which way? Up, down, left, right. To the left. Remember, you got to think opposite, right? Since it's a plus 2, you think to the right, but no, it's to the left. Think opposite. Switch your thinking. Okay? Cool. That's what we're looking for, right? That's what we're doing. Okay? This one here, the next one, I have no. How about the minus 2 on the outside? If it's on the outside, it's a vertical something, right? We're adding or we're subtracting by 2. So it's a shift by 2 units to the what? Up, down, left, right. Down. Right? Okay? This one here, let me erase this, actually. This one here, there's 2 transformations. There's a 5, and there is the -3. 5 would represent a vertical because it's on the outside. We're multiplying, so it's going to be a stretch or compress. But now we know it's going to be a stretch, right? Because it's the whole number on the outside that we're multiplying by a factor of that number 5. Okay, so we're multiplying it by 5. Everything grows by 5. How about the -3 on the inside? Inside, so it's horizontal. Shift, because we're adding or subtracting. 3 units. Up, down, left, right. To the right. Awesome. Okay. All right. And then the last one, I'll let you guys do and think about for yourselves. Okay? Questions? So that's what the lesson is.